Hello there. Okay, with bell work, today I just want you to take a guess on how tall do you think Freddy the Firebird is. This shouldn't take you very long, but I do want you to share it with your person next to you and tell me why you think that Freddy is that tall, or think if you can come up with some mathematical way of doing it. So I think on this bell work will just take about 2 minutes. You can pause the video. And when you guys are ready, we will move on. All right, so I want you to think about it. Can you find the height if you know that you are standing 18.1 feet away at a 30-degree angle? Can you solve this using Pythagorean theorem? Or maybe using special right triangles? I'm not going to answer this, but I want you to discuss this with your neighbor. Take a couple minutes to do so. You can pause the video. All right, so today you'll be doing an activity, and I've put you guys into groups. So if you need to, you can pause here and take a look. 4th hour, you will be, these are your groups. 5th hour right here, and 7th hour here. I'm pretty sure I got everybody. If I missed someone, then join one of the groups of 2, please. Okay, and these angle measurements here are the angles that you will be assigned for the activity. So please jot that down as well. If you need to, you can pause on this screen here. And go ahead and move to your groups. All right, for this activity today, you've each been assigned a certain angle measurement. The substitute will have a sheet of triangles with that angle. So you'll collect that from the substitute. Don't do that yet. Go ahead and listen to these instructions. With your partner, you will measure the length of the opposite side, which should be labeled, the length of the adjacent side, and the length of the hypotenuse on all 8 triangles, and record them onto your table. There's a half sheet that the substitute will give you for recording onto this table. Okay. Once you're done measuring the length of each side, I want you to find the ratios that compare the opposite to the hypotenuse, the adjacent side to the hypotenuse, and the opposite side to the adjacent. And you're going to record all of those, I believe, in decimal form. And I want you to observe what you notice once you get all 8 of those done. Okay. If you need to, you should probably pause on this screen so that you don't forget what the instructions for the activity are. Okay. At this time, I'm hoping you're done with the activity. Now, I want you to know, could you use one of those angles to find the height of Freddy? So, whatever group has angle 30, why don't you share what your ratios are and talk with your class about maybe finding the height here if you know the ratios. My hint to you is to set up a proportion. Again, I'm not going to solve this one with you. We'll talk about it when I get back. But think about this 30 degrees and those ratios. Okay. I know this is going to be kind of hard to see, but I want you each to compare how close your measurements are to this table. So when you were finding your ratios of opposite over hypotenuse and opposite over adjacent and adjacent over hypotenuse, how close did they come? So like if you were 20 degrees, your opposite over hypotenuse, did you come really close to 0.3420? When you did your adjacent over hypotenuse, did you come really close to 0.9397? And when you did your opposite over adjacent, did you come really close to 0.3640? So you might want to pause here so that you can kind of see. I know that it's really small, But see, did you guys come really close? And then to discuss it with another group and see how close they were. Let's go ahead and pause. Okay, so a few quick notes I wanted to take with you guys today. The topic, Intro to Trigonometry. The essential questions for today: what are the parts of a right triangle, and how can I use trig ratios to solve for the missing sides of a triangle? So we are starting trigonometry. Trigonometry is the branch of mathematics dealing with the relations of the sides and the angles of the right triangles. Okay. So there are parts to a right triangle that you've already dealt with here. We have the opposite side, the adjacent side, and the hypotenuse. The hypotenuse, remember, is always across from 90 degrees. So if my 90-degree angle is here, this will always be my hypotenuse. It is also always the longest side of a triangle, of a right triangle. The reference angle theta is what we'll call it, is the angle that I'm telling you to deal with. So in this case, I'm saying this one down here in the corner, so we'll call it theta. If I wanted to, I could use this one. But for this example, theta is this one down here. Okay. The adjacent side is right next to the reference angle. Remember, adjacent meant next to. So I have theta, I've got the hypotenuse, and then right next to it is the adjacent side. And that means opposite of the reference angle is the opposite side. So here's this opposite side. Okay, so please draw that into your notebook. If at any time you need to pause the video, you sure can. Okay. A trigonometric ratio is what you were finding when you did this activity. It's a ratio that describes the relationship between the sides and the angles of a triangle. What we are going to use are right triangles. I'm hoping that you noticed that for each pair of complementary angles, there is a family of similar triangles. So the ratios will be constant no matter what. So when you're looking at your 8 triangles, they may have had different side lengths, but their angle measure was the same. So the ratios that you found should have been the same or very, very close. Okay. In any right triangle, the ratios of the legs and the hypotenuse are related to each other. So trigonometric ratios, we have 3 different kinds. We have sine, cosine, and tangent. The sine ratio is the opposite over hypotenuse. That should have been the first one you calculated. So make sure you write these down. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Same picture here. Where's the opposite side? All of those things. But in a right triangle, we will compare ratios of the legs and the hypotenuse so that they're related to each other. I want you to make sure you have this in your notes. Okay, and that's it for notes today. We're going to talk a lot more about trig ratios when I get back. Talk about what sine, cosine, and tangent means and how we use them to find missing side lengths. So make sure you get all the notes down. No homework tonight. Yay! And that's it. So have a wonderful day.